solve a radical equation, we first have to know its definition. A radical equation is an equation in which the variable appears in the radicand. For example, square root of x plus 7. It is an example of a radical equation because under the radical sign is the radicand x, which is an unknown variable. Another example, square root of x plus 2 equals 3. It is also an example of a radical equation because there is a variable x that appears in the radicand. And lastly, square root of 2x minus 3 equals square root of x plus 5. Again, this is an example of a radical equation because there is a variable x both in the left side and in the right side of the equation. To solve a radical equation, we use the fact that if two numbers are equal, then their squares are also equal. In symbols, if a is equal to b, then a squared is equal to b squared. For example, let us try to solve this radical equation square root of x plus 2 equals 3. Now we have to use the property if a equals b, then a squared is equal to b squared. So since it is stated in the radical equation that the square root of x plus 2 is equal to 3, we may use the property a squared equals b squared, so we can raise the two sides of the equation by 2. This means that their squares are also equal. Now we may cancel this out because it has an index 2, and then on the left side of the equation only x plus 2 will remain, and on the right side is 3 squared, which is equal to 3 times 3, and that is 9. And then we can now easily solve this equation. The next thing that we have to do is use the addition property of equality and add negative 2 to both sides of the equation, and then simplify. Negative 2 plus negative 2 is equal to 0, so in this left side only the x would remain, equals 9 plus negative 2 is equal to 9 minus 2, and that is 7. Therefore, the value of x in this radical equation is equal to 7. And to check that, we have to substitute our final answer against the original equation. Our original equation is square root of x plus 2 equals 3. Now let us substitute our computed value of x, and that is 7 plus 2 equals 3. And 7 plus 2 is equal to 9. And the square root of 9 is equal to 3. Therefore, we can say that our answer, x equals 7, is correct. To solve a radical equation, arrange the terms of the equation so that one term with radical is by itself on one side of the equation. Square both sides of the radical equation, combine like terms. If a radical still remains, repeat steps 1 to 3, and then solve for the variable. And of course, check apparent solutions in the original equation. For example, x minus 6 equals square root of x. So the first thing that we have to do is to raise both sides of the equation by 2, because we have an index here that is equal to 2. So we may now cancel this out, and then on the right side of the equation, the radical will be also cancelled out and x will remain. On the left side is the quantity of x minus 6 squared, and that is equal to x minus 6 times x minus 6. And then expanding this equation, we have to use the FOIL method. Okay, so we have to look for the first terms, and those are x and x, and we have to multiply it. X times x is equal to x squared. Next are the outer terms, and those are x and negative 6. X times negative 6 is negative 6x. Next, inner terms. The inner terms are negative 6 and x, which when multiplied will give us a product of negative 6x. And the last terms, which are negative 6 and negative 6, which when multiplied is equal to positive 36 equals x. Simplifying this further, by combining like terms, the left side of the equation would be equal to x squared. Negative 6x minus 6x is equal to negative 12x plus 36 equals x. Now, we have to use the addition property of equality and then add negative x to both sides of the equation and then simplify. X squared, and then combine negative x and negative 12x. That would be equal to negative 13x plus 36. Right side of the equation has x plus negative x, which equals to 0. Now, to solve for the value of x in this equation, we may use the method of factoring. And then look at the first term, which is x squared. Think of two numbers which when multiplied is equal to x squared. And those are x and x. And then look at the constant term or the last term, which is equal to 36. Think of two numbers which are factors of 36, that is when multiplied will give a product of 36. And those are negative 9 and negative 4, because negative 9 times negative 4 is equal to positive 36. And to check if our answers are correct, we have to multiply the middle terms, which are negative 9 and x. Its product is negative 9x. And then multiply the outer terms, x and negative 4. X times negative 4 is equal to negative 4x. And then add. Negative 9x plus negative 4x is equal to negative 13x, which is the same as our middle term, negative 13x. Okay, now that we have proven that our factors are correct, we may now proceed to the next step, which is applying the zero product property, which states that if one of the factors is equal to 0, then the first factor may be equal to 0, or the second factor is equal to 0, or both the factors are equal to 0. So let us take the first factor, x minus 9, and equate it to 0. Same as the other factor, x minus 4, equate it to 0. And then solve for the value of x in each equation. In the first equation, x minus 9 is equal to 0, we have to add 9 to both sides of the equation and then simplify. 9 minus 9 is equal to 0, so only x would remain, equals 0 plus 9, and that is 9. So we have our first value of x, 9. On the second equation, x minus 4 equals 0, we have to add 4 to both sides of the equation and then simplify. 4 minus 4 is equal to 0, so only the variable x would remain, and 0 plus 4 is equal to 4. And we have our second value of x, positive 4. And the last step is to check whether our answers are correct, and we have to substitute our two computed values of x against our given equation. So our given equation is x minus 6 equals square root of x, and we only have to substitute our computed values of x. So the first value of x is 9, and let us substitute it to our given equation. The x here would be 9 minus 6 equals square root of x, which would be a square root of 9. 9 minus 6 is equal to 3, and square root of 9 is also equal to 3. So the first value, x minus 9, is correct. The second value is x equals 4. Now let us substitute into our given equation. X minus 6 equals square root of x. The x here would be substituted by 4 minus 6 equals square root of x, which would be square root of 4. 4 minus 6 is equal to negative 2. And the square root of 4 is equal to positive and negative 2. Therefore, we can say that this value x equals 4 is also correct. 4 plus square root of x minus 2 equals x. The first thing that we have to do is to arrange the terms in this equation so that all the variables in this equation are on the same side of the equation. So using the addition property of equality, we have to add negative 4 to both sides of the equation and then simplify. On the left side, since negative 4 plus 4 is equal to 0, we may not write it down, so only the term square root of x minus 2 would remain. And on the right side is x plus negative 4, which would be equal to x minus 4. And then now we may proceed to raising both sides of the equation by 2 to eliminate the radical sign. So the left side would only be equal to x minus 2, and the right side would be equal to x minus 4 times x minus 4, since it is also equal to x minus 4 squared. And then again, use the FOIL method. The first terms are x and x, which when multiplied would be equal to x squared. The outer terms are x and negative 4, which when multiplied is equal to negative 4x. The inner terms are negative 4 and positive x, which when multiplied also equals to negative 4x. And the last terms are negative 4 and negative 4, which when multiplied gives a product of positive 16. And then just copy the left side of the equation. And then, by combining like terms, the right side of the equation would be negative 4x minus 4x, that is negative 8x plus 16. Now we have to use the addition property of equality to simplify this equation further. We have to add negative x plus 2 to both sides of the equation. On the left side, negative x plus x is equal to 0. Also, positive 2 minus 2 is equal to 0. So on the left side, we have to write 0. And then x squared, 8x minus x is equal to negative 9x. Positive 16 plus 2 is equal to positive 18. And then we may use again the method of factoring. Look at the first term of this equation, x squared. We have to think of the two factors of x squared, and those are x and x. The next step is to look at the constant term 18 and think of two numbers which are factors of 18, of positive 18. And those are negative 6 and negative 3. To check our factors, we only have to multiply the middle terms and the outer terms, and those would be equal to negative 6x and negative 3x respectively. Then add. This would be equal to negative 9x, which is equal to our middle term. And then we may now proceed to using the zero product property and then equate each factor to 0. So the first factor is x minus 6. X minus 6 equals 0. Also, the other factor, x minus 3 equals 0. And then solve for x to both equations. On the first equation, we have to add 6 to both sides and then simplify. And since 6 minus 6 is equal to 0, only the x would remain, and 0 plus 6 is equal to 6. Now we have our first value of x, positive 6. On the second equation, x minus 3 equals 0. We have to add 3 to both sides of the equation and then simplify. 3 minus 3 is equal to 0, so only the x would remain, and 0 plus 3 is equal to 3. The second value of x is positive 3. And the last step is to check whether our answers or our computed values are correct. Let us check the first value, x equals 6, and substitute it to our original equation, 4 plus x minus 2 equals x. Okay, so all the x's in this equation would be substituted by 6. 4 plus 6 minus 2 equals 6. And 6 minus 2 is equal to 4. Mine equals 6. The square root of 4 is equal to 2. And 4 plus 2 is equal to 6. Therefore, we can say that the first value of x that we have computed, which is 6, is a correct value of our radical expression. Now let us check the second value of x, which is positive 3. Our original equation is 4 plus the square root of x minus 2 equals x. So this would be equal to 4 plus 3 minus 2 equals 3. 4 plus the 3 minus 2 is equal to 1. And the square root of 1 is equal to 1. 4 plus 1 is equal to 5. And it is not equal to positive 3. Therefore, we can say that x minus 3 is not the right root for our given radical expression, and our only root is equal to positive 6. For our last example, m equals the cube root of 16m. So the first thing that we have to do is to raise both sides of the equation by 3, because we have an index here that is equal to 3. And then simplify. On the left side is m cubed, and on the right side we may cancel the index and the exponent, so that would also eliminate the radical sign, and only the radicand 16m would remain. To solve for the value of m, we have to divide both sides of the equation by m and then simplify. We may now cancel this out, and 16 would remain. And then m cubed divided by m is equal to m squared. And since we have an exponent, we may use the property and we can take the square root of both sides of the equation and eliminate the exponent. So that would be equal to m, and the square root of 16 is equal to 4. So we only have one value of m. The next step is to check whether our answer is correct. For m is equal to 4, our original equation is m equals the cube root of 16m. So let us substitute m by 4. This would be 4 equals the cube root of 16 times 4. 16 times 4 is equal to 64. And the cube root of 64 is equal to 4 because 4 times 4 times 4 is equal to 64. Therefore, we can say that our computed value of the variable m, which is 4, is correct.